And I'd just like to give you a quick lesson here on how to use the cross-reference and the find all tool when you're trying to troubleshoot a problem. And the problem we're trying to troubleshoot is I have a flashing jog light on my control panel, and I'm trying to figure out, well, what is that flashing jog light telling me? And there's a find all tool at the top here, and if you type in jog up there, it'll find everywhere in the program where the term jog is used. And if you look down at the bottom here, it shows me everywhere it's used. And there's XIC bits that have the word jog in. You'll see there the word jog. OTEs. You see, well, there we go right there, jog light. That's exactly what I was looking for. So I can see my jog lights flashing here. I can get rid of this find all now. Found it pretty quick for me. And if you look at this rung, there are several branches to this rung. And you'll see this first branch, it has one bit on, but not this bit. So that's not what's causing it to flash. You go on down the line, and you'll see this highlighted bit. When it's highlighted, that tells you it's true. And as you can see, when this goes true, our OTE goes true. And by the way, in Logix 500, you'll see this description here. It's O3. O means it's a real world output, and that's my light flashing. So I find that this motor needs service bit is on, and you have to figure out, well, what exactly does that mean? That's a bit, but it doesn't really tell me a whole lot. If I right click and go to cross-reference, it'll take me here. It'll show me everywhere that that address is used in the program. And you'll see there's an OTE right here. Again, go to the OTE. And there's the OTE flashing. Well, what's making that OTE true? Follow that back. There's a flasher bit here. Well, off the top of my head, I know that that's just a bit that's throughout this program. Anywhere you want to make something flash, you use that bit. But the real problem is you'll see there's a motor run timer here that went done. And when you see a DN bit with a timer, that tells you that that timer timed out. So again, right click, cross-reference. I'm going to scroll up so I can see everything that has T43, because as you can see, this is T43 done. T43 done is right here. That's what we were just looking at. So here's the actual timer itself, the retentive timer on, RTO. Go there. And that you can see that anytime this fan motor starter is on, it makes this timer time, and when it hits an accumulation value of 10,000, the bit goes done. So this preset here is always the same, that never changes. The accumulation value is going to go from 0 to 10,000 as this thing runs. So I can see that that's why my bit is flashing, and that done bit makes that flash. Now, how do we reset this timer? So let's make believe like we took care of this motor and we serviced it. Maybe we had to go out and grease it or whatever we're supposed to do at 10,000. In this case, it's actually 10,000 seconds, which is a little unrealistic, but anyway, it's great for this presentation. Again, cross-reference T43. You'll see there's a reset. We want to reset that now because we went and serviced this motor. We want that light to stop flashing. Here's another done bit that resets it. It says hold OGS to reset. Well, if you look right above here, this is T44. This is a brand new timer. We haven't looked at T44 yet. Well, T44 happens to be right here. We need this to go done. Now this is a timer on delay. If you look up here, remember this is retentive timer on. So retentive timer on is going to retain its value, and if you shut the motor off at 5,000, it's going to hold that 5,000 value until you start the motor up again. Well, a timer on delay doesn't work that way. A timer on delay, if you watch this bit go true, you see it starts counting, and if I release that bit, it goes back to 0. So this is not retentive. This does not retain its accumulation value. So what I need to do is I have a little button here I'm pushing. I need to push this button for 10 seconds and watch what happens over here at 10 seconds. At 10, the done bit went true, and I'm still holding it, by the way. And this went and it reset our accumulation value up here. Now if I release it, we can actually see exactly what happened there. Our fan motor starter's on, the retentive timer is timing. Now if I stop the motor, see it's going to hold that 14. Start the motor, and she keeps going. And even if I wanted to reset this before I even get to 10,000, if you look down here, I'm going to push this again until I get to 10. It's going to reset T43 again. See, T43 went to 0 because I'm still holding this button down. As soon as I release the button, it's going to start again. So anyway, that's some good troubleshooting tools to use, especially using this Find All tool. It took us right there. And the right-click cross-reference is very effective. Again, if I look at my cursor here, if I wanted to find the reset for this timer, right-click cross-reference, RES, reset, takes me right there. So there's a short little lesson on cross-referencing and using the Find All tool. In my classes, we do a lot of cross-referencing because I realize that that's the key to navigate large programs, is understanding how to get to the OTEs and that they control a lot of what's going on. And I'll put some more lessons out here soon. I hope this is helpful to you. And if you have any questions, please email me at info@midwesttechtraining.com. Thank you.